The next thing I want to talk about is the source transformation. So let's see how it works. The source transformation is that, so we have the Thevenin and we have the Thevenin equivalent and we have the Norton equivalent, and says they are basically the same. They do the same thing if we have them. So assume here I have a Thevenin equivalent of like that. So positive, negative, and then I have this goes toward the RT and why so. So it goes toward one end and then the another end, and assume I call again these E and F. So this is the VT and this is the RT. And we know that we can replace, so we can replace any circuit with the Thevenin. At the same time, we know also we can replace it with the Norton. So if I have the Norton, it's going to be IN. And then I have this time I have the resistance in parallel. That's going to be NF. It's going to be R, T, E, and F. If I have this, I can basically I know that I can replace every circuit that I'm given with the Thevenin. This is the Thevenin, or we can replace it with the Norton. So these two basically behave in the same way. So whatever happened for the EF here, it's going to happen the same for the EF here. They behave the same way. Knowing that, sometimes I can just replace these two with each other. So if I have a circuit, and in my circuit, I have a battery in series with the resistance. If I have a battery and series with the resistance, I can remove these two and replace it with the current source in parallel with the resistance, with the same resistance. Or the other way around. If in my circuit, anywhere in my circuit, I have the sources, the current sources in parallel with the resistance, I can get that part and replace it with the battery with the resistance in series, with the same resistance in series. So in other words, I can come here and get this part of that. And replace it exactly with this anywhere in my circuit. So I can replace these green dashed line with each other. If I have one of them and it's easier to switch it to other one, I can replace this box with this box, or the other way, I can replace this box with this box, depend on if it's going to make it easier. The only thing that you have to remember is that there's the IN, the value of IN is going to be VT divided by RT. So this is what you have to remember. So this is the magnitude, the value of the IN. And the other thing you have to remember is the direction of this arrow here. This arrow should be toward the positive sign of that. So this positive and arrow should have always the same way. So if the positive is up, like here in the battery, you have the positive, is the positive is toward E, so the arrow should goes toward E. The same if the positive was the other way around. If this one was positive and the above was negative, then the arrow should be down. So remember that if this is the positive negative, the arrow should always follow that, or the other way around. If the arrow goes up, then the positive is up. If the positive is up, the arrow goes up. So the arrow and the positive sign always should be at the same side. Remember that. So for example, if the battery was like this, then the arrow should be like this. Right. Now here the positive is on the top, is toward the top, so the arrow is toward the top. Is the positive is toward the bottom, the arrow is going to be toward the bottom. That's the second point you have to remember when you use the source transformation. Okay, now let's look at an example to see how we can use this source transformation. So assume we have a circuit like this. So I have a battery, 12 volt, and that 12 volt goes into resistance R1, which is going to be 5 ohm. And then here, and then we have another resistance here is R2. So it's R2 and it is 10 ohm. And then we have a current source that goes like that as a 1 amp. And if we have I in this wire is going to be I1, and I in the second wire is going to be I2. So assume we want to find the magnitude of the I2. So how we are going to do that? So look at here. I can do this in two ways. So here I have a battery in series with the resistance. Also, I have the current source in parallel with the resistance. So I either can take these two and replace it with the, so these two is like the Thevenin, and I can replace it with the Norton. These two are similar with the Norton, I can replace it with the Thevenin. So first, to show how we can do that, the first thing is I'm going to do is that I take these two and replace them with the resistance and a battery. So the first step is that replace these two with the resistance and battery. So these two is going to stay the same. So I have the battery, 20 volt, and I have R1. The R1 would stay the same as it is. Now I replace these two with the resistance and the let's say what's the battery. So the resistance is always going to be the same. So if it's R2, this one becomes R2, and then this becomes a battery. The arrow goes up, so positive is going to be at the top, and then so I replace this with this one. Now look at this. So I know this one. I know the R1 is going to be 5 ohm. I already know that. The R2 is going to be 10 ohm, so the R never changed. Now I know to need the voltage here, and for the voltage here, for example, I want to know what's going to be the voltage here. So I know the IN. The equation I have is the VT divided by RT. So here, IN is 1 ohm. Look at here, the IN is 1 amp, sorry. The VT is the one we want to find out. And the RT is this. It's going to be that 10. So the VT is going to be 10 volt. So it's going to be 10 volt here. So now I have this circuit, and look at the I is going there. So the I is going to be that I1 because it's the I1 going in that circuit. Now that I have the voltage, look at the circuit. It's a very simple circuit. You have 2 battery, 2 resistance, and you want to find the I1. So the next step is that I will go ahead and write the KVL at that KVL in this circuit. So it tells me the sigma V is 0. If I start from this bottom node here, it's going to be negative 20 volt here, and then I have the voltage in this resistance is going to be I1 R1, which is going to be I1 times 5, plus the voltage in this one, which is going to be I1 R2, so I1 times 10, and then here I received it, so it's going to be plus 10 volt, and it's going to be 0. And if I solve this, is going to tell me the I1 becomes 0.667 amp. So this is the I1 that I have. So if I go back to the original circuit now I know the I1. Now if I write for this top node, the KCL for the top node, CL for top node, what I have for the KCL for top node is going to tell me sigma I is going to be 0. So the I1 goes in, the 1 amp here goes in, should equal to whatever leaves. So the I2 is leaving. So therefore, I know the I1 is, so the I2 is going to be 1 plus 0.667 amp, which is going to be, 1.667 amp. So this is how we can use, so this is how we can replace the left part of that circuit to come up with this circuit. Let's look at it again. So how I did that, how I replaced that. So let's go back here. I can replace the current and the resistance. If I have a current source and resistance with the, I can replace it with the voltage and the resistance. So here I have a current and the voltage and the resistance in parallel, this part. So I can go ahead and say, let me draw it with the other color. So I can go ahead and say I have the current source and the resistance like that. So this is what I have here. This is 1 amp, and this is the R2. Now I can go and say I want to replace this with the voltage source and the resistance. So I'm going to go ahead and say I will replace that with the voltage source and the resistance. Like that. Yeah. So I can right now grab this part, this right part, and replace it with these two, and it's gonna be these two here. Basically, it's gonna I replace them with, so it's gonna be R2, and it's gonna be the volt. So that's how I come up with this one to this one. The second method is that, again, now go back here and said, if I not the other way around, if I have the battery and the resistance, I can replace them with the current source and resistance. So look at here. Now I'm gonna draw the left part of that here. I have the battery and the resistance. So I have the battery, that 20-volt battery, and the resistance, this part, and it's going to be R1, and this 20-volt battery. Now I can replace that with the current source. It goes up because the positive is up there, and the resistance, the same resistance, but this time in parallel. So it's going to be R1. So I will go ahead and do that. I replace these two with this format. So if I go ahead and do that, this time I change these sources here. So I replace them with the sources. So I replace these two, like here, with these two. So it's gonna be a current source, and because the positive is up, so the arrow should goes up, and then I have the resistance, the same resistance in parallel, which is gonna be it's gonna be R1, and it's gonna be 5 volt. And then I draw just the rest of the circuit here. The rest of the circuit is R2 and this one. So the rest of the circuit is going to be R2, which is 10 ohm, and the sources that we already have on the left side of the circuit. So it's going to be like this. Now we know this is the 1 amp, and this we know the R1 and R2 is going to be the same, so we know the values of them. Now we need to find the IN here. See how much is that IN. Again, we know that the IN is this equation, so it's the VT divided by RT. And if I go ahead, the IN, how much is the VT? The VT is 20 volt. And the RT is R1 here, which is going to be 5. So the IN is going to be, comes out at it as 4 amp in this case. So we have a 4 amp here, so it's going to be equal to 4 amp. Now look at here. So I want to find the I1 and the I2 in this case that we have it. So I know this one is I2 here, so I know it's going to be I2 here as well, because the same thing here. It's going to be I2, but here whatever goes through that, whatever it is, we don't know what it is, so I'm going to call it I3. So I3 go through that, I2 go through that, because this part, the right part of the circuit hasn't changed. The right part is the same as it was here. So the I2 and I2 is going to be the same. The 1 and 1, everything is the same. Now look at here. I have two parallel resistance that the current goes through them. How much current goes through them? We have 1 amp here and 4 amp here. So in total, 5 amp is going to be splitted between two parallel resistance. If we go back and remember the current divided method, can go back and look at it. Current divider was like that. If you have a current and you have two resistance, two parallel resistance, the current is going to be divided between them. So the total current we have is 5 because 1 is here, 4 is here, so 5. And it's going to be divided for them. So if I use that current divided method, the I2, and it's going to, if you remember, is proportional to the reverse of the um, uh, resistance. So it was, can go back and look at the equation. So the I2 was proportional to the magnitude of the R1 and times the I total. That was the current divider method. So the I2 is going to be R1, which is going to be 5. And then R1 plus R2 is going to be 5 plus 10. And the total current is going to be, again, I have 4 amp here, 1 amp here. So totally I have 5 amp going through that. And if I have written everything right, it should come out at 1.6. It should come the same as what we have here. So it shows how you can, if you have, how you can replace the source and the resistance with the similar one. So here I have a battery and the resistance. I can replace the battery and resistance with the current source and parallel resistance. Or on the left side, I have the current and current source and parallel resistance. I can replace it with the battery and resistance.